Welcome to this tutorial of our Shear Wall Designer Program, an intuitive and powerful tool for parametric design of planar shear walls.
The graphic user interface, or GUI, consists on the main menu with tabs and options for common operations, and a ribbon that allows quick selection of most used functions. The combo boxes on top allows for selection of design code and seamless transition between international and imperial units. The figure on top shows a plan view of the wall being analyzed. The bottom figure consists on the interaction diagram for the wall's strong and weak axis. The design variables are located at the left side, and a summary of results are shown at the bottom. To begin our analysis, we will define load combinations or demands for the wall. This can be done via Edit, Load Combinations, or using the ribbon icon. We can add these directly on the form where we will need to provide a name for the combination, ultimate axial force, moments in the strong and weak axis, and shear force in the strong axis.
However, it's usually more practical to import load combinations from a file, which can be the tabulated results of any analysis program. The program allows importing any number of combinations from a comma-separated values or CSV file. These are simple text files, but these type of files can also be opened or created in spreadsheets such as Excel.
In this example, we will import a total of 20 different load combinations. And now we are ready to run our analysis.
As shown on the interaction diagram, some of the loads fall outside the interaction or capacity curve for the strong axis. This gives a clear indication of failure, which is also reported in the summary of results area. We can also request a more detailed report of results using the Display Results table option.
Here we can review results for each load combination. In this case, we can see how the worst combination for axial flexure is combination 6, which is what the program reported in the summary of results. Results for shear design for each combination are also reported here. As we can observe, there are various combinations that are causing failure in shear. The tabulated table of results can also be saved as CSV file for further evaluation or post-processing using spreadsheets. Since it's clear that the wall is not working for the demand in either flexure or shear, we will need to address these. Let's unlock the model and review axial flexure first. There are a few things we could do here to improve wall capacity. In this case, let's assume that the wall geometry cannot be changed. The more efficient way to improve flexural capacity is usually to increase size and number of edge bars, so let's give this a try, and notice how the wall plan figure is dynamically updated as soon as a variable is changed.
Now we can run the design using the updated reinforcement layout. We can notice how the interaction curve increases, providing enough capacity for the demands. This is also reflected in the summary results. Let's now address shear. There are usually two ways to increase shear capacity. One is to increase wall dimensions, which in our case is not an option, and the second one is to increase concrete strength. We will use the latter and increase the strength to 5.5 kSI.
We notice that this is enough to improve shear capacity and avoid failure, resulting in a design that works for all load combinations. Let's now review another option of the program which allows the use of web rebars for compression. The default option assumes detailing as shown on this sketch. This is web rebars are not confined. In general, using this bars in compression is allowed when bars are appropriately confined as required by code, as shown on this detail by using rebar ties. This is usually not as economical, but it may be required in some seismic regions. As expected, engaging web rebars for compression increases the capacity curve. It is important to notice that edge rebars are always used in compression, therefore, they need to be appropriately confined.
We can now do a last review of tabulated results and compare governing load combination in the table and with summary results, which highlights the governing load combinations and demand capacity ratio for axial flexure design, and the governing reinforcement and combination for shear.
The program can also display a three-dimensional plot of the biaxial interaction surface, which can be used to further review results. The plot offers various options like rotation, zoom, and can also be saved as an image. Lastly, we will save the model, and we will explore the option to generate a report.
First step is to enter information about the project which will be included in the report. Then a report in PDF can be generated for the shear wall design, which will include all relevant information about the current dimensions, reinforcement layout, and design. This concludes this tutorial. Please let us know of any questions in the comments, and if you found this video useful, don't forget to subscribe to our YouTube channel.